Hello everyone, myself Meghana MJ, second year computer science and engineering student from Sri Venkateshwara College of Engineering, Bangalore. Today I am going to discuss about the topic called random variables, probability, mass and density functions, mathematical expectations and its applications in mathematics subject. Introduction to random variables. Random variables are numerical outcomes of random phenomena. They are classified into two main types, discrete and continuous. Understanding random variables is fundamental in public probability theory. Discrete random variables. A discrete random variables can take on a countable number of distinct values. Examples include the number of heads in coin toss or the roll of dice. The probability mass function is used to describe their probabilities. Continuous random variables. Continuous random variables can take on an infinite number of values within a given range. Examples include heights, weights, and temperatures. Probability density function characterizes the distribution of continuous variables. Probability mass function. The PMF gives the probability that a discrete random variable is exactly equal to a specific value, and it is a function that assigns probability to each possible value. The sum of all probability in a PMF is equals to 1. Properties of PMF. PMF must satisfy two core properties, non-negative and normalization. Each probability assigned by a PMF must be greater than or equal to 0. The total probability across all over outcomes must to sum to 1. Probability density function. The PDF, which means probability density function, describes likelihood of a continuous random variable taking on a specific value. Unlike PMF, PDF do not provide direct probabilities for specific values. Instead, probabilities are found over intervals by integrating the PDF. Properties of PDF. The PDF must also satisfy non-negative, meaning it cannot take negative values. The total area under the curve of a PDF across the entire range equals 1. The probability of a continuous random variable falling within an interval is given by the area under the PDF over the interval. Comparison of PMF and PDF. PMF is used for discrete variable while PDF is used for continuous variables. PMF provides probabilities for specific outcomes, whereas PDF gives probabilities for ranges. Both are essential for understanding different types of random variables. Applications of random variables. Random variables are widely used in statistics, engineering, and finance. They help in modeling certain uncertain outcomes and making informed decisions. Understanding their distributions is crucial for various analytics methods. Conclusion. Mastering random variables and their functions is key to probability theory. Both PMFs and PDFs serve critical roles in statistical analysis. A solid grasp of these concepts enables better handling of uncertainty in real world scenario. And the mathematical expectation and its applications. Introduction to mathematical expectation. Mathematical expectation, also known as expected value, is a fundamental concept in probability theory. It represents the average outcome of a random variable when an experiment is repeated many times. Understanding mathematical expectation helps in making informed decisions under uncertainty. Definition of mathematical expectations. The mathematical expectations of a discrete random variable is calculated by summing the products of each possible outcomes and the probability. For continuous random variables, The expectation is determined using integrals overall over the probability density function. The formula for discrete random variables is e, e into x. E of x is equals to summation of x. The expectation operator is linear, meaning E of ax plus by is equals to ae of x plus be of y for constants of a and b. If a random variable has a probability distribution, its expectation exists under certain conditions. It is important to note that the expectation does not always equal any possible values of the random variable itself. In gambling, mathematical applications in gambling and games. In gambling, mathematical expectation helps players assess and the fairness of games. Players can calculate their expected losses or gains to make strategic decisions. Understanding expectations can lead to better betting strategies and risk management. Applications in economics and finance. Economists use mathematical expectations to evaluate investments, risks, and returns. Expected value calculations guide decisions regarding stock selection and portfolio management. In finance, the concept helps in pricing options and derivatives based on expected future cash flows. Applications in insurance. Insurance companies utilize mathematical expectation to set premiums based on expected claim amounts. The concept the concept helps in calculating the risk associated with different policies. By understanding expected losses in insurers can maintain the probability while providing coverage. Application in statistics and data analysis. In statistics, the expectation is used in estimating population parameters from sample data. It assists in hypothesis testing where research evaluate expected outcomes under specific assumptions. Mathematical expectation is foundational in creating statistical models and interpreting results. Applications in operational research. Mathematical expectation is crucial in operations research for optimizing resource allocation. It assists in decision making process such as inventory management and production planning. By evaluating expected outcomes, organizations can enhance efficiency and reduce costs. Limitations of mathematical expectation. One limitation is that mathematical expectation may not account for variability and risk adequately. It can be misleading in the presence of skewed distributions where outliers affect the mean. Decision makers should consider additional matrices such as variance or standard deviation alongside expectation. Conclusion for this concept. Mathematical expectation is a powerful tool for analyzing random variables and making informed decisions. Its application can span various fields, including finance, insurance, and statistics. Understanding expectations enhance our ability to navigate uncertainty and optimize outcomes. And these are the reference for the topics. Thank you for listening my video patiently. Hope you all understand about the topic. Thank you.